Good evening, everyone, and welcome to the Formula Bharat Academy session hosted by Ather Energy. This evening, we have Hari Vasudevan, System Intelligence, and Suraj Vallamkonda, Product Design Engineer of Vehicle Chassis from Ather Energy, both Formula Student alumni, who will be answering your questions relevant to Formula Student. We have already received a host of queries via the form that was available on our website, but we will also take further questions via the YouTube chat box if time permits today. A bit about our speakers today. Hari Vasudevan holds a doctorate in mechanical engineering from Yale University, specializing in control systems, and has worked in the controls and signal processing space for more than 10 years now, helping create products at both startups and established companies such as Apple Inc. At Ather, he is responsible for PMS and system algorithms under the System Intelligence umbrella. Hari has also been a part of the FSAE hybrid team from Yale University that competed and won at FSAE Hybrid 2013 at Dartmouth College. Suraj Vallamkonda is a postgraduate in mechanical engineering from IIT Madras. He's been an active member of the FS circuit for 9+ years, which is 5 years as a participant and 4 years on the organizing committee of Formula Bharat. He has spent more than 4 years with Ather. He has played a major role in designing Ather 450's first of its kind aluminum steel hybrid bolted chassis. He has also developed his own internal design tools which help design engineers in reducing their dependence on simulations. Over the past year, he's been looking into supply chain quality, setting up processes at the supplier to ensure part quality, and is currently working alongside the battery engineering team to increase battery robustness and helping scale up the production volumes. Hari and Suraj will speak about a bit about their FS experiences before we move into the Q&A session. Hari, Suraj, please go ahead.
Hi everyone, I'm Hari. So before we start session, maybe I'll talk a little bit about my FS experience. So I was mostly part of Bulldogs Racing, which is the FSA team at Yale, and I was associated with them somewhere between 2012 and 2014. 2013 is when we raced the BR13, which was our car in New Hampshire. And it was a great experience. It was a confluence of the right people at the right time with the right leadership. More my experience in Formula has mostly been about late nights, you know, laser cutting acrylic to build battery packs and so on. And also at the track trying to fix, or rather trying to convince safety judges about the rating of a particular insulation material so that we pass the safety trials. Um, if I had to say something about FSAE, other than all of the rich experiences that it has brought us, it is that test before you put it on the track. If you think that by testing you'll blow something up, you'll almost certainly blow that up on the track. The other couple of points are always carry a MIG welder, and also keep track of your crimping tools while you're on the track. They can walk away. So that sort of sums up my experiences at FSA. Over to you, Suraj.
Hello everyone. This is Suraj here. I've been part of Formula Student for about 9 years now. 5 years as a participant between 2011 and 2016, and 4+ years on the organizing committee. Some of you might have seen me at technical inspection usually. So yeah, we will start answering questions from whatever you guys have sent us. But at the end, if I have time, I really want to speak about how different this year is going to be for the entire community because of the pandemic and all the complications that it has brought along with us. Right. So no college for a year, teams taking a break, alumni will then have to step in. So all those sort of complications, right? So yeah, let's see if we have time, we can talk a bit about that. I guess we'll get started.
Let's
Yeah.
get started.
So let's get started with some of the questions that we got on the form.
So the way we thought we'd do this is maybe we'd pick up one question from the list that was sent to us, and then as and when questions come in, we will try to alternate that with the questions that get sent live right now. So let's see. The first question is on system reliability and robustness. I'll read out the question. How do we say the system is reliable? How is it defined? How to make it reliable? The question is based on electronic circuits, harnesses, etc. So there's a short and long answer to this one. My short answer is have the vehicle ready a month before the competition. Now that is not always possible. I mean, most teams get it ready about a week before the competition, or even less, or maybe at the competition. So that's the short answer. The long answer is use industry standard harnesses. Some of the harnesses that you use in the labs and so on, while they may seem great for all of your testing purposes, they during the vibration environments they usually come loose. These are you have trouble with crimp quality, with spring loading in connectors. Stay away from Anderson connectors that I found out during my Formula days. They're great for testing low voltage electronics, but they are really bad in on the track. The other sort of point that I want to sort of stress on is there are no shortcuts in wiring. Um, you know, you have always been tempted to take shortcuts if A and B are connected with a cable, and then you realize that you want to connect C to it. There is a tendency for the low voltage electronics, at least there's a tendency where you would strip out the cable in between and try to put a solder joint there and connect to something else. So stuff like that makes your vehicle less reliable. And ultimately in Formula, it's reliability. From my experience, it's reliability that wins the race. It's there are cool features that you can add. If you can pull them off, that would be great. But it's usually reliability, reliability, reliability. So the short answer is be make sure you have time to test your vehicle before the track. That is sort of the only way to make sure that it is reliable. If you can do formal design, I mean, if you can, like use PCBs wherever possible, use them, reduce wiring. That sort of generic advice is always there, of course. Unless you have something else also.
I think you've answered everything on that.
All right. Great. So that was one. Let's see if we have any other questions that have come in. I'm not sure if no, nothing yet. So I guess the second one is also electrical. So I'll try and take this one. How to tackle noise issues due to power electronic devices in a car? What testing has to be done? So a lot of these noise issues are actually tackled with the Formula rules itself. From my understanding of them, right from the time that we built the car way back in 2013. Make sure that your low voltage and high voltage grounds are separate, physically separate low voltage and high voltage boards. Maybe that may not be there explicitly in the rules, but if there is any low voltage, high voltage boards that are in close proximity to each other, separate them. And one more thing that I mean, this is prevalent in this industry also. If you're using analog signals, please use low pass filters as part of the design. Analog low pass filters. There are many instances where I've seen an analog signal connected directly to a ADC. Having an LPF as part of your electrical design will save you a lot of grief, because of this. It'll avoid high frequency crosstalk that comes from mainly any switching FETs or your motor controller and so on. So those are sort of the main three things that I can think of. The other one, of course, test at full power. See, even if you have your car up on on the gantry, try to test at full power in some way, and that will tell you what is the maximum crosstalk that you can see on the vehicle also. So that's sort of a set of generic rules of thumb, I think, that you can use to get around this. Maybe we can take a mechanical one.
Yeah. So let's go to the next question. The next question is on wheels and tires. So this question is by Uzair, and he asks, in the upright of a wheel assembly, is it better to use a single double row bearing or two single row bearings? Right. So that's the question. Now this is a very specific to a car answer, right? There is no general rule of thumb which says which is better, is it A or B. The way I would like to look at a similar problem statement in design would be to compare the pros and cons for multiple effects, right? So specific to this, I would look at, and the different line items would be, I would like to look at manufacturability. What I mean by manufacturability is on your upright and your wheel hubs, what is the sort of manufacturing method that you are using, and what is the kind of tolerances that you will be able to achieve, right? So if you're using one single double row bearing, then you only need to worry about the outer diameter and the inner diameter of your shafts. But if you're looking at doing two single row bearings, then you will have to also control the distance between the two bearings, right? So the cylindricity of your machining and the accuracy will come into picture, right? So manufacturability would be the first thing I would consider. I would also look at the performance, right? With a double row bearing, you're kind of limited on what is the performance you can extract out of this bearing, right? But if you use two single row bearings, then you can play around with the dimensions of each of these. You can play around with like what distance you mount them at, which will give you a better torque resistance, right? Or in other words, it will give you better stiffness on your entire wheel assembly, right? So that would be the second thing I would consider, or second parameter I would consider. The third parameter would be cost, right? Are you willing to spend a little bit extra to buy two bearings, or do you just want to buy one bearing, play it safe, have a high factor of safety, and keep things within your budget, right? So that would be cost. And the fourth parameter I would look at is weight, right? Like both of these might weigh similar, but it depends on what kind of architecture you have on your assembly. If you want to keep the two bearings a little away from each other, put a spacer in between and clamp it, that might be slightly heavier than, you know, just having a single double row bearing, right? So these would be the four parameters I would want to look at. If I go back to when I was a student, what we found the most difficult to do was to achieve manufacturing tolerances, right? Because all of these are made at a prototyping vendor, like somewhere on the outskirts of Chennai. Explaining GD&T and tolerances to him would be a nightmare. And we also did not have enough time to rework a part, right? You make a drawing, we release a drawing, and he will just give it to us. And we only have time to just take it and put it on the car, right? We don't have enough time to do a different trial. We don't have time to modify anything if it's gone wrong, right? So I would always play safe with respect to manufacturing and tolerances. So I would just pick a bearing which would require which would have the least amount of dependency on tolerancing. But now at Ather, since we have better facilities and also more design levers, I would kind of look at having two single row bearings and keeping a certain distance with them between them and clamping them through a spacer, right? It allows for a better control over cornering stiffness, and it also allows you to like be a little lower on weight, right? But for sure it's more expensive, right? So depending on what stage of the journey you are as a team and the kind of experience you have with your car, the kind of resources that you have exposure to, you will have to make this call depending on your team, right? So that's what I would say. Anything you have to add to this?
That's about it, right?
All right, so let's go to the next question then.
All right, so I'll read out this question. This is from Shiva Teja. Shutdown sequence is a very long circuit that runs throughout the car. Since it is long, there's considerable drop in voltage across the wire, so it won't be able to power the AAR adequately. Any hint in how to make this robust? So this is a little bit related to, I think, the rules on Formula Bharat, where the shutdown sequence is long. But first I would ask the question, that, I mean, we see problems like this all over in designs, right? I mean, it's not just restricted to Formula Bharat. I mean, this could happen here at Ather too, right? When we are prototyping something. So my question would be, is this really the root cause of the problem? Because yes, we do see a voltage drop, but is it a gradual voltage drop from the length of the line from the beginning to the end? Right? That would be something to investigate first. And if you do see that that is the problem, the idea would be to see, is this drop happening sort of like all at once, or is it actually happening gradually? Because what typically happens is, when you have connectors, if you use any sort of connectors, depending on how you have crimped the connector versus the contact resistance of the connector itself, you will see a drop just across a particular set of bad connectors. So it could be something that is not related to the wire length at all. It could be something that would be as arbitrary as, say, a connector, right? Then of course, some of the other things that you realize while wiring up a car is that there are probably different ways to wire the car. um, the the length of the wire that you loop around the car, there's probably another way to loop it around the car that is more optimal than the way that you do it the first time around, right? And it usually again comes back to the time you have got to spend on the car. Now, the tendency is to, once it works, you have to go and if you see that this voltage drop is there, it's a pain to remove all of the wiring from the back end of the car to the front end of the car, remove all the wire ties that come with it, then redo the connectors, redo all of these things, and then rewire the car. So some of these problems end up with, there's a shorter path. Maybe if we rewire it a different way, the problem might just go away, right? So part of it could be that. The third possibility, of course, that yes, there is this problem. Now, what do you do about it, right? One thing to do is to see if the lead acid battery that you use, or any battery that you use to charge your low voltage electronics, if you can bump that up a little bit, right? And use a higher battery, so that the voltage of the battery doesn't drop during operation. And say if you're supposed to maintain at 12 volts, maybe the other components can usually tolerate anywhere between like some 13 volts to 11 volts or something. There'll be some internal regulation for the digital components. So you try to bump up the voltage a little bit, use a higher amperage battery, and use that to sort of power all the way down to your AARs. So it could be any one of these combinations. I would say start with, is it really the root cause? And start with checking your circuit at every point, and then sort of work your way down to more complex solutions as you go through this process. Yeah, I think that was it. Let's see any other.
Okay. Yeah. So let's look at the next question, right? So then the next question was on drivetrain. I'll read out the question. The question says, we were using sprocket chain drive in our vehicle, and now we decided to shift ourselves to a limited slip differential. So what are the technicalities and engineering calculations and research that we are required to do in order to integrate this into the vehicle properly and be functional? Right. So the first thing I would like to say here is that a chain sprocket and a limited slip differential are not mutually exclusive, right? A chain sprocket is just transferring power from your engine to the drive, to the rear wheels. Your differential is just deciding how to distribute the power between your left and your right wheel, right? Depending on what is the load on each of these wheels, right? So they're not mutually exclusive. You will see cars with a rear sprocket and a limited slip differential, right? So I believe what this question means is that you were probably running a solid axle in the rear, and now you want to move to a differential. So I think you're asking me, is it good to use an LSD? By LSD I mean a limited slip differential, and what other things we need to consider for this, right? So I'm going to answer that question. In case that was not the question, please unmute yourself and we can have a conversation, right? So first thing I would like to say is that there's a lot of information that's already available on the FSA forum that talks about how you want to select your differential, right? On not all cars is LSD your best option to use, or it's not the best design choice to make, right? Depending on your car architecture, you will have to decide if you want to use like a torsion differential, if you want to use limited slip. I've seen cars with a solid axle which is really quick on track, right? So it depends on how good your driver is and whether he can extract the best out of a solid axle. Um, in like you've seen go-karts, right? Go-karts have always been solid axles, and you've seen how quick the drivers are, right? So it all depends on how you build your car around, or how you actually build your driver to extract the maximum out of the car, right? So it's again a design choice that you have to make. There is enough information that is available on the forum, so I don't want to look at the general topics here and tell you this is what you have to consider for a differential. Like a quick 5-minute read on the forum will give you all this information. What I would really like to talk about is that whatever you decide, right? Like at the end of the day, you will do your own pros and cons. You will analyze it. You will decide what you want to use, but try not to just buy it off the shelf and put it on your car, right? End of the day, it's a design competition. We are looking for students to use their creativity. You like get your hands dirty, understand every single thing in the component, and then put it on your car. And that way, you will know why your car is behaving in a certain way, right? And you will also understand engineering better, right? So I would suggest, even if you have decided you want to use a limited slip differential, do some benchmarking, right? Look at other teams which are using this, open these differentials up, see what is there inside, see how you can just make things cheaper. Probably, can you make it lighter? Can you manufacture it here, so that you can get it done faster? This year, due to pandemic, like the whole transportation industry is like gone for a toss, right? So you won't get imported parts very easily, all of that. So do that sort of an analysis. When I was a student, we actually completely re-engineered a gearbox from the Civic, and we actually used the differential for almost 3 years, right? We completely changed the steel body into aluminum. It was just plain reverse engineering, and we managed to pull through 3 competitions with that, and that helped us save a lot of money, which we put into a better component on the car, right? So focus on that. Don't just buy something off the shelf and put it on your car. Look at how you want to redesign the gears, make it lighter. Most of the differentials you get off the shelf are built for OEMs. By OEMs, I mean like cars on the road, which are built for a durability of 1 lakh kilometers, 2 lakh kilometers, different driving conditions and all of that, right? But as a race car, you have a very specific use case. You're just going to run your car for probably 500 kilometers to 1,000 kilometers. It's a very controlled environment. So you can actually optimize your gearbox a lot, right? You can go smaller on your gears. You can go much thinner, much lighter. Because it is rotational inertia, it will help you save a lot of efficiency across the entire drivetrain, right? So explore all of that. And in the journey, you will also get to learn a lot about gear kinematics, which will eventually help you in your career, right? I would really encourage you guys to do that. Also, do a lot of reverse engineering, right? Even if you don't understand how a certain thing works, just break it open and try to replicate the same. And when you put it together and you test it, you will understand a lot more about the design, right? So go hands-on, go dirty. That's what I would say. Right. We can go to the next one.
Yeah. Let's see.
It's done.
I think we have taken that.
Suraj, Hari, I just wanted to let you know Nashit is in the room. So if you did want to have a conversation with him, you can.
All right. Okay.
Understood. So I'll read out the question. Maybe you can go first.
Sure.
So Nashit has a question. Since Ather Energy is the first electric automotive industry in India, what are the chances of young technical engineers to be working in electric automotive sectors in upcoming electric vehicles era?
Right. Nashit, yeah, you can actually unmute yourself, and if you want
Yeah,
to
sure, sir. Can you hear me, sir?
Yes, we can hear you.
Good evening, sir. Yeah.
Yes, Nashit, go ahead. Is there anything else you
Yeah,
want to ask? Or?
No, I don't want to add anything. This was my question actually, because I'm looking for a really good opportunity here. So right now I'm doing certification in electric vehicles. So I was looking for the opportunity, and this link came up. So I thought I was curious to ask this such kind of questions.
All right. Okay. So I'm just going to give you a very generic answer as to how the industry is evolving, right? One, the entire automotive industry globally is moving more towards electric powertrains. I wouldn't say electric, but more efficient powertrains. And it is also moving towards user experience and ease of driving, right? That is why you're seeing autonomous driving. You're seeing cars with alternate powertrains, some electric, some are doing hydrogen cells, some are doing solar, all of this, right? So these are the two primary directions in which the industry is going. And India is also trying to be at the forefront of a lot of this, right? If not as complete vehicle manufacturers, there are a lot of smaller companies that are building hardware, building technology that will eventually be used in these sort of applications, right? So I think there's a wide variety of opportunities that are available, irrespective of which domain you're in, right? You could be in hardware, you could work on batteries, you could work on electrical integration, you could work on like what else? Cells, anything else, right? And there's you actually have an opportunity for each of these, right? What else? Yeah, do you have anything else to add to that?
No, I got my answer actually. So there was no confusion in it. One more thing I want to add here is that is there any chances? See, like in so I have been told in 2040 or 2030, in 5 to 6 years, maybe or 10 years, the whole automotive sector will be electricals, right? So the company who are starting up, there are a lot of startups who are working in electrical industries. So those startups need more engineers, right? So they cannot work on limited staffs. They would be needing more engineers. They would be needing more technical engineers for different departments. So what are the chances for them to cooperate and to have a contribution on the company and to increase the employment sector of the in country? That's what I'm saying. In this particular sector.
So yeah, Nashit, you're right. So I mean, the industry is undergoing a change right now. The employment potential of the industry, of course, I mean, predictions are hard to make, but I think it's a safe bet to say that we see the percentage of electrics on the road to grow from now on, right? The exact percentages as to how many will replace IC engines on the road, that would be hard to say, but we at Ather at least are optimistic that we'll be able to make an impact on that. So in that sense, the opportunities for engineers are there. And like Suraj said, the opportunities are there in various disciplines. They are there in, maybe the BMS design. They are there in the drivetrain design. And even in some areas like at Ather, the vehicle is not just the BMS and the motor, right? So the vehicle now has been reimagined to have components that connect to the cloud, for instance. So you have a data intelligence portion of the vehicle also, right? So the field is expanding in many directions. I'll also add another point that we see globally that the industry is changing. But one point about India is that a lot of the technologies that have been developed internationally still need to be adapted to India in some way. So, for example, right, the drive cycles that are typically uh, used internationally may not be the drive cycles that are there for used in Indian conditions. The reliability metrics that are there internationally are not the reliability metrics that are there in the Indian market. The temperature ranges for which components have been qualified internationally are not the temperature ranges that we see in India, right? I mean, if you take any of the Western countries, there's a fair assumption that you need enough low temperature proof materials that you can put in a vehicle, but they may not see the temperatures that we see in India. For
Correct,
example,
correct.
like we don't see as many low temperatures in most of India as Western countries see on a yearly basis, right? And we see higher temperatures in India than most Western countries see on a yearly basis. So in that sense, the durability cycle of each of the components is also different. And this affects everything on the vehicle, from uh, the materials that you use to build the vehicle, to the cells to the way in which you have to qualify the cells, as well as the safety limits of the cells and the algorithms that control the charge and discharge of the cells. The drive cycle that we have in India controls, for example, will change the way motors need to be used in India, right? Because their efficiencies happen at different parts of the torque speed curve.
Correct.
So,
Yeah.
so there's a whole bunch of these factors that will be specific to India and may not directly translate from development that has been done necessarily elsewhere in the world. So in that sense, there would be opportunities in India going forward in engineering vehicles or EVs for the Indian market also.
Yeah,
Okay.
and just to add to Hari, I would like to say, this is where these student competitions come into the picture, right?
Correct.
There are committees like Formula Bharat. There are several other committees where you as students can go participate. And through the whole experience, you will understand what it takes to get your product running in India, right? You can't just copy any standard that comes from Europe or something, because their use cases are totally different from what we need, right? Something very similar to Percy, right? Like we use a standard Percy, which is actually built for a European
The standards
more
are
of a
different from the
European,
international.
right?
The standards are different, correctly. The
Right.
standards are different, you're saying.
Yes, and the way Indians are built, the whole build is different, right? So the whole percentiles change over here. And this is the experience which will actually make you more and more valuable to any industry that you join. Right?
Correct.
This is the time that you'll never get back, and this is something unique that you as a student will develop.
Thank you, sir. Yeah, that will be all.
All right.
Thank you, Nashit. Thank you, Suraj. Thank you, Hari. We'll now move on to the other questions as well.
Right. Okay. So I'll go to the next question. This is on chassis and composites. I'll read out the question. So it says our team is aiming to transfer to a monocoque chassis from a space frame chassis. So what are the considerations we should take in terms of materials, composite, in terms of the material of the composite, simulation, physical testing, or any other parameter to bring this into reality? Also, what is the estimated budget based on your insights? Right. So before I answer this question, I like if this person's on the call. Okay, he's not on the call. Right. So again, more generically speaking, I would like to understand why this team wants to do this. Right. What like from the question, I understand they probably do not have enough experience in building composites. Right. And when you don't have all this experience, what is that motivating factor which is driving you to build a monocoque? Right. This is not me commenting, but this is every team or every team captain. This is what you should be asking your team member or your team in your general meetings, right? If say you want to build a monocoque chassis, right? What is the primary motivating factor for you to do that? Is it weight? Is it benefit in stiffness? Is it cost? Is it like what else? Is it freedom for design? Are that your benefits? And once you write these benefits down, it is more important for you to write down the cons as well, right? Or what are the challenges in this whole process? You will be lighter, fine, but what is the manufacturability? What facilities do you have close to your university that will help you bring this monocoque into reality? Can you do this within the stipulated timeline of your competition? Do you have enough budget, enough resources to do this? Do you have the freedom to service your chassis, right? Say something goes wrong in the competition and you want to change a certain element or change something on your monocoque, right? So how are you going to do this? I've been part of the organizing committee for 4 years now. Every year there's not more than a handful of teams who have not visited hot pits, right? I can barely count 5 to 10 every single year. This means that teams are coming to the competition and also changing their chassis or bits and pieces of the chassis regularly, right? So as a team, are you confident of taking that call early in the year, saying I'm going to make a monocoque, this is going to be my chassis for the rest of the year, I cannot do any modifications to this, and will all the other benefits outweigh this particular risk that I have going into the year, right? Then what are the challenges with respect to manufacturability, reliability? How will you test all of this? The risk of delamination, right? Multiple things that will come in, right? So the way I would look at this is, um, as a team captain, or as one of your principal engineers who's actually going to make this decision for the whole team, right? Weigh your benefits against all the challenges you're going to face, right? You're going to face challenges in terms of manufacturability and also in terms of knowledge as a student team, right? And apart from knowledge as a student team, the kind of guidance that you can get from your alumni, from faculty, and also from industry support, right? Like different companies you can speak to. So only once you have a good understanding of this, jump into manufacturing a monocoque chassis. Right? For the last 2 years, I think we have seen around 3 or 4 cars that came with monocoque chassis to Formula Bharat. Uh, the cars are good, but we have not really seen the best of the potential that they can pull out of the monocoque, right? Most of the time, the effort that's gone into building the monocoque has meant that they were not able to put enough effort into other subsystems of the car, which eventually kind of brought the whole team down, right? So what I would suggest is, before you jump into a monocoque, start small, right? Look at ways in which you can develop capability within your team to manufacture composites, to test them reliably. Uh, like just make components like steering wheel, just make the carbon fiber seat. You can start making bodyworks out of carbon fiber, or aerofoils like your wings, front and rear wings, out of carbon fiber. This will just So these sort of components are components which are not taking too much of load. It just needs to have a certain shape. So you can, even if you go around slightly, it's not going to hurt you at the end of the day, right? Once you do this, you have a basic understanding, then move to components which can start taking some load, right? Look at making A-arms out of carbon fiber. Look at making your steering column out of carbon fiber. You can do, what else? Pedals made out of carbon fiber, right? So these are components which can take load. And through this whole process, you will learn about how you simulate loads for composites, and also how do you manufacture them reliably, right? So if you're not laying these, if you're not doing the layup properly, if you're not giving enough time for vacuum curing, and if you're not putting it in an autoclave to a certain temperature, these will start building cracks, or internal voids will be there, which will mean that your component fails, right? And when you compare your simulation against your failed component, you will know exactly where you're going wrong. And you will then incorporate that into the monocoque that you will make maybe next year or the year after that, right? So this is where the competency of a team has to build, and it is important to build that competency, right? Don't always jump into doing something cool just because everyone else on the globe is doing this, right? Till today, I have not really seen a car which has maximized its potential of cornering stiffness, right? Everyone says I want a certain stiffness, but then fine, you get that stiffness on paper, but on the track you're not really extracting all the performance due to that stiffness, right? um, Fine, a monocoque chassis is on paper lighter than a space frame chassis, but have the teams that have already made these in the last couple of years, have they been lighter or not, right? Also, say you're saving what, 5 kilos from your monocoque. Can you extract these 5 kilos on other components of the vehicle, right? Say you keep your space frame exactly the same. Can you optimize your suspension? Can you optimize your steering? Can you optimize like what else? Your rear bulkhead, right? Also, your rear bulkhead plate, if it's made out of carbon fiber, is going to save you at least a kilo on the car. And while you're doing all of this, you give enough time for your team to develop that competency by making other components on the car, right? Also, look at last minute weight additions to your car, right? Like you go to hot pits, you weld a bracket, you weld anything else to make your car rigid and clear tech. All of that is added weight to your car, right? So can you build that competency internally to build your car a month in advance, get your alumni to do technical inspection for you, and that will help you save time and also weight of your car, right? And it's also that mental anxiety that you will have at the competition. So these are things which are important for you to consider before you make such important decisions of moving to a composite, moving to a monocoque, right? Best features that made it to the design finals, right? Every design judge actually looks at the understanding of the engineer of whatever he's built. And it's not about, has he built the coolest thing out there? Is it the most cutting edge technology? It is not about these sort of things, right? So you're like, honestly, it is better if you make an honest appraisal of yourself, rather than just trying to do something that is a little far-fetched for that particular year, right? So you'll have to make this call as a team along with your alumni, and also looking at the kind of resources you have in terms of external support and sponsorship, right? So uh, that's what I would like to say. Now, answering this question in particular, what consideration should we take for composites? Again, this depends on what is a composite, what layup you do, what is the resin that you're using, what is your method of curing of the composite. So I can't really give you a general answer. It'll help you if you go through the process, just building small composites one at a time. Simulation, again, it's very similar. You can just make a small bar out of composite, put loads in XYZ, put a moment, put a strain gauge on it, try seeing what is the strain you get, then simulate the same thing on your computer and see if the strain values are matching, right? And once you get that, you have some sort of a correlation between your simulation and your real vehicle. And this is also what will help you build the car. And eventually, this is something that will help the design judges understand that you know why you've done things a certain way, right? Then what about the estimated budget to build a monocoque? This is it's slightly difficult. It's definitely going to be upwards of 1 lakh. If you want to do like a vacuum chamber and an autoclave to cure your whole monocoque, it is going to be even more expensive. I believe you should work towards getting these facilities either from your university or through any industry, right? So if you're somewhere close to Bangalore, you can talk to ISRO. Chennai has a lot of institutes that offer autoclaves on rent for students. Also start talking to teams who can start talking to companies who can sponsor carbon fiber as a material to you. That will also help you save cost, right? But more than cost, your biggest challenge is going to be competency, and that is what you guys need to focus on. All right, sorry for the long answer of a short question.
That's okay. That's all right.
There's something on simulation somewhere. Electric modeling.
D'accord.
One on top of that. So I think Nashit is there. Maybe he can answer that. Nashit, would you be able to clarify this one question that you had put up in the forum? How long will it take for the motorsport industry to adapt electric modeling for racing competitions? What will be the success rate? I'm assuming this is generic vehicle modeling, right? Or is there something specific that you wanted to ask?
Nothing specific. You got it right. Actually, I wanted to ask more specifically, what are the chances the electrical engineering would come into motorsports industries? That was my main idea.
I think that I'm not sure about racing competitions. For the more sophisticated competitions, I'm sure that it's already done.
Okay.
I mean, at Ather, we take modeling very seriously. We do modeling for almost every aspect of um, of the design process. It like essentially what is modeling generally is it helps you build confidence on your final design before you make your final design, right? And you're able to iterate on it. I mean, as it is for CAD, it's a similar process for any sort of either algorithm design or any sort of electric circuit and so on, right? So what will be the success rate? I think that's a harder question to answer. I think most famously about simulations, I think it has been said all simulations are sort of doomed to succeed. But that being said, simulations are still very useful at figuring out what you should not do, and when you're doing something decently, how to do it better. So I wouldn't say that simulations are the answer to everything, but if you have something that works in reality, simulations will help make that better. And it will also help you quickly evaluate concepts, and sort of like discount some concepts, and use the others, right? I mean, for example, I mean, take something as simple as your motor controller, right? What current limit should you put on your motor controller for a formula competition, right? If you have a very basic mass and model of mass and drag on your vehicle, you will be able to evaluate what acceleration that gives you versus how long it takes for your battery pack to discharge completely, right? And that will let you make a decision on either sizing the battery pack, or it'll help you make a decision on what is the max acceleration you want to get out of your vehicle. Do you want your vehicle to be fast but not like last very long, or do you want to retune your vehicle between sort of legs of the competition so that it achieves both objectives in some way? So you'll be able to take those decisions more easily. And I think in just that alone, it is sort of a valuable tool. um, do you have anything to add?
No, not it.
So thank you, sir. That will be all.
Thanks,
Thank you,
Nashit.
ma'am.
Yeah, thanks.
Thank you.
You
Okay,
want to take this?
sure. So this is a question from Surbhi Singh. How should we proceed for DAC if we are doing it for the first time? Okay, so I think this is again one of the questions that has a sort of a broad answer. So maybe I'll talk about it for a bit. So the first question any team that sort of has to ask themselves is, what is your budget / sponsorship situation, right? Um, or more broadly, I mean, take a step back and see that, okay, you need a certain set of voltages to be able to control your vehicle in some way, right? If you're using off the shelf components and doing a system integration exercise, they will already have a lot of this built in. So you don't need to do separate, build a separate DAC, but your vehicle will still run and it will still sort of like finish the competition, right? If you're a team that is at a stage where you, because of the legacy of the previous years, you already have a good vehicle and a decent architecture, and you're trying to make a delta change to make sure that you have substantial change from one year to the next, so that you're able to sort of like put the car in, then it might be a good problem to take up, right? Say now we are saying that, okay, all of the data acquisition and control you're going to do on your own, right? Or even the supervisory system, you're sort of revamping it on the vehicle. In that sense, it will be a good project to take up. So it has to be another decision that's based on the architecture of your vehicle versus how much confidence you have in the vehicle itself. It might be that time might be much better spent on improving reliability of your vehicle, for example, right? The second question you have to sort of ask is that, what is your budget or sponsorship situation, right? So if you have a budget, or if you can convince a company to give you a DAC system, say if you have NI as a sponsor, for example, right? Like, are you able to convince them to give you a DAC plus a LabVIEW license, right? That will make your situation much simpler than if you go with, okay, I don't have sponsorship for this, but I'm going to use an Arduino to do all of the DAC, and I'm going to set up all the analog sensors via a PCB that I design on the vehicle itself, right? Now that will take you a lot more time. Then it'll take you a lot more time debugging all of the data acquisition on the Arduino, and then figuring out a transceiver to send it somewhere else where you want to look at the data, analyze the data, store the data, and all of that. So every team sort of has to take a step back and decide, is what is the best use of our time, right? The short answer to the question is that yes, I mean, you can use any variety of data acquisition systems, everything from a LabVIEW to some sort of instrumented Raspberry Pi to an Arduino. But for your situation, what is best sort of needs to be decided by each team individually. Yeah, I think that's sort of all I have to say about that.
Okay. We'll just take questions that have started coming in from chat now. So there are actually two questions which are kind of related, so I'm going to answer them now. The first question is, what are the most important points that should be kept in mind while doing mechanical design and simulation? And the second question, slightly related to this, is at Ather, what are the designing methods and considerations while manufacturing a chassis? So I'll try to answer both of these. Right. The first thing I would say is when you're doing design and simulation, always also focus on validation. Right. When you're sitting on a computer, everything is ideal. Your design is ideal, your simulation is ideal, but in the real world, there are a lot of variables that you do not consider when you're actually simulating, right? So get into the habit of doing quick design, doing quick releases, and also building a lot of prototypes, right? At every small step, just build a prototype and validate the assumptions that you've made, validate some of the major decisions, and then move on to the next stage of design, right? At Ather, we have this value which we call as move fast and don't break things, okay? So that's a very specific value for Ather. And what move fast and don't break things means, get into the habit of doing rapid design and prototyping cycles so that you de-risk yourself from major failures throughout the product cycle, right? Say you are designing any component for parameter A, B, and C. Then once you kind of have a design that will more or less achieve parameter A, build a prototype and validate it before you start optimizing it for parameter B and then parameter C, right? So as students, I would request you guys to do the same. Do not spend a lot of time optimizing for every single gram on the vehicle. The more time that you give yourself for testing and manufacturing, it will benefit you massively throughout the whole cycle, right? So in a year, given that you have competitions for 3 months and exams, like in a 9-month window, I would personally say give just 3 months of your time for design, manufacture for 4 months, test for 4 months, right? Don't try to keep your design cycle for 6 months. It just takes up a lot of time that you will better utilize if you had a car that is built and running, so that you can make quick changes to the car then and there, right? Also, when you're building your car, keep some room for making changes later on, right? Like have some degree of freedom in your say you're doing the suspensions, keep some degree of freedom to change the toe, change the camber angle, all of that. On your in the cockpit, give enough space for the pedals to be moved forward or back depending on who your driver is. These sort of things, right? So depending on whichever component you're working on, do not go completely optimistic and don't just optimize every single thing. Give some like we call it a design lever, but like what I would say is keep some factor of safety everywhere, right? And this is also similar to the approach we use at Ather, right? While designing a chassis, the most important thing for us and the challenge that we faced was that there is no particular standard to which any chassis is built in India, right? You don't have like a homologation standard. You don't have like any load standard or any drive cycle which says, hey, if you want to build a vehicle, this is the load that has to be applied. These are the kind of roads it will run on. This is the life for which the vehicle has to be running, right? So there's nothing of this sort. You will see, especially in India, you will see like 4 people riding a two-wheeler. And also you will see a two-wheeler being ridden on a very, very smooth highway at like 150 kilometers an hour. And also at villages with like horrible roads at 20 kilometers an hour with like 3 people sitting, 2 gas cylinders and a kid at the back, right? So these are the variety of load cases you will have. So the first challenge we faced was to write down all these load cycles and kind of define our own internal drive cycle, right? What we mean by drive cycle is a certain cyclic load on the chassis, which if we multiply enough number of times, will kind of define the durability of the vehicle for the entire life that it serves, right? So, like I said, these like even the drive cycle is an assumption that we make very early in the product life cycle of the vehicle. And this was the first thing that we validated, right? We just made one chassis, put it out on the road, did a whole bunch of testing on it, and just validated our assumption, right? If 5 people sit on that vehicle, does it break, right? If 3 people go like climb a hill with that vehicle with like additional load, they hit a bad pothole, like the temperature of the motor and battery is maxed out, what happens to the vehicle, right? Does it survive, or is the vehicle fine to be used, right? So these are sort of assumptions that we kind of validate very early in the process, and then through every single prototype you keep optimizing it till you reach a state where you have achieved your target, right? In Formula Student, you will keep optimizing it till the competition, right? You eventually run out of time or you run out of money, right? So that is the process that we kind of follow over here. Right. There is also a question on this. Do you want to take that?
Okay, the question is, on a business point of view, how did you start Ather and how did you manage to get the capital? Now, I'm sorry, I cannot answer this question.
Oh, I can. Okay, I can give you some context. Okay, so Ather was started by. I'll just answer this in quick 2 minutes to kind of give you an insight as to how Formula Student can lead you to different places, right? Ather was started by 2 graduates of IIT Madras, and this was like their thesis in their final year, right? When they were doing their masters, Ather was a thesis project. They graduated, they worked, and one of these founders is a Formula Student alumni, right? After they graduated, they joined different companies, quit very quickly, and then decided that they will want to build this vehicle, right? And on day one, they did not know what are the specifications of the vehicle, and they also did not know how long it is going to take, and also what is the amount of money it's going to take, right? Like we officially launched a vehicle in June of 2018. Till 6 months, like till Jan 2018 and like late 2017, we were always saying that we are just 3 months away from production, right? And that 3 months eventually was like ended up to be 5 years and also like millions of rupees and dollars, right? So to put things short, what I'd like to say is anything that you put your heart into, be it Formula Student or any other project that you're doing, you can go and make it big. You will obviously not know every single step of the journey when you start it off. But if you have the determination, you'll just keep like progressing one step at a time, and eventually you'll be at a good place, right? So I always say this as an example for people to not get or to not get intimidated by the size of things, right? I'm sure on day one, if someone would have gone to Tarun and Swapnil and said, hey, it's going to take you 5 years to launch the vehicle, you will need 400 people and it's going to cost you X millions of dollars, I'm sure they would not have done this, right? They would have just continued working in whichever company they were in, right? So yeah, that's one perspective that you can take away from Ather's journey so far.
Right. Are we over time, or I think maybe one more?
You can take a few more questions.
Yeah.
You can take a few more questions. That's fine.
So maybe I'll take one on the electrical side. So this question is from Sai Kiran. How can we apply the concept of signal processing / control in the development of EV? So, I mean, I will say on the outset that, like all the concepts of signal processing and controls are relevant in the development of EVs. However, my take for Formula students is don't try to use the concepts because you want to use them, right? Use them so that you can solve a real problem on the vehicle. And this also plays to the point that Suraj first said, that you must be able to explain every part of the vehicle and why it worked and why you took the decisions that you did, right? So for example, right, take signal processing, right? Say you have a DAC system, as we had talked about earlier, and say if you're sampling the signal, right? As I mentioned earlier, like in a lot of places I've seen, for example, the low pass filter that is sort of skipped from here, right? So in the hurry to do digital signal processing, which is on the processor, you miss out on one step, which is that on the electrical board design, there had to be something more fundamental sort of built in, right? Which is the low pass filter. So yes, you need to use all the fundamental concepts that you learn from signal processing in the car. So say you have a velocity signal that you have already digitized, but that is very noisy, and you want to filter that because you're using it for something else, right? So that would be a legit application, right? But the process to getting to using something like that or doing something like that on board should come from the application and not from the need to let's do DSP, right? Let's figure out coefficients from MATLAB and apply it on this process over here. So all the concepts and controls are used in a commercial vehicle like Ather. Like, I mean, we have charging controllers, we have discharging controllers, and we do plenty of signal processing on board. But as a formula student, you have to sort of strategize as to which part of the component of this chain that you want to build. um, uh, Often in a year you might just be able to build maybe one part of it, and that part of it must have significance for your vehicle, and not as a way to use a particular technique that you want to use. So that's sort of the point I'll make on this. But generally, coming to the problem itself, how do we apply these concepts? There are a variety of tools that you can make use of. I'm sure TI, of course, has a whole bunch of open source tools for design of filters and so on. MATLAB, to which I think most academic institutions have free licenses. There's a whole bunch of design tools in MATLAB itself, and MATLAB also has the ability to sort of generate code from your Simulink model or from your script itself, right? So you can use those tools to sort of realize what you want to do on the vehicle. But I would say keep the target in sight. Use it to solve a real problem on the vehicle. So yeah, that's sort of that. Let's see. Do we want to take any of those?
Okay.
We do have a question which just came in with regards to on-track tuning for a Formula Student vehicle.
Right. Yeah. So the question says, do you have any pointers for setting up a Formula Student car related to on-track tuning? Right. I can take that. But before I say that, there's one thing I would also like to say. This year is like super unique for the entire competition, right? Due to the pandemic, there's been no competitions for a year. Alumni in their final year have graduated, so your team is more or less going to be new. There's a lack of experience. There's also cars which are like built in like in a half built state with people moving out and new people having to complete the build, right? So one general thing I would say is for all alumni who was on the call, your team needs you more than you know, right? Like this whole year you have to probably spend 50% of your time doing knowledge transfer to your juniors. Don't try anything radical in design. Like as soon as you guys get back to university, start building car, you will figure things out on the way. It is okay if you bring like a car which was very similar to your previous years to the competition, because this year is all going to be about knowledge transfer, how well your team understands an older car, and also this kind of determines the journey your team is going to have in the next 3 years, right? Because it's going to be these people who are going to take it forward, right? So spend most of your time on that. Don't spend too much time in designing or in completely changing changing the concept of your car, right? Now coming back to this question, how do you basically do on-track tuning, right? So what I would suggest is spend a good 4 to 5 months just testing your car out, right? You need to have at least 600 to 1,000 kilometers of mileage in the car. I don't know if you guys do much higher, but in India, the maximum I've heard is 1,000. I've heard European teams do much higher.
Yeah, there are also teams that get their car to start working on the track.
Yeah, true.
So
That happens too.
that too. So,
Right. So aim towards getting at least 500 kilometers under the belt. Right. How you would like to start off is just identify drivers at least just one or two drivers. These drivers need not be the fastest drivers, right? You need to understand you are just testing your car. You have not put it out on track yet, right? So identify a driver who will consistently be able to drive the car in a particular path, right? So if it's a figure of 8, your driver should be able to like drive it at a constant speed on that path without like even moving out by centimeters, right? And he should be able to do this probably for like uh, 10 or 50 laps at once, right? Just so that you get enough data that you can use. If your driver keeps going wide, or if his path keeps changing, or if his speed keeps changing, you will not really get any data from which you can make decisions, right? So focus on getting a good test driver, someone who can consistently ride your car in a particular manner that you want it to ride, right? Once you've done that, start working on the basics, right? Just start with straight line acceleration, right? Is your car able to accelerate at the same time that you simulated for, or what you designed for, right? If not, try understanding why it is off. Is it off because your gauge changes are not on time? Is it off because your engine torque is not really going to your wheels? Are your wheels spinning? Is it off because your grade ratios are not exactly what you designed for? Is it off because your weight is higher than what you estimated, right? Understand all these things and then try to rework your simulations for other components, right? Once you're done with straight line, start looking at figure of 8, or even before figure of 8, just do constant radius turns, right? Start off with a very slow speed, high radius, constant turn. See if your car is doing what you actually assumed it will do, right? And then start going faster and faster. Then you start going like reducing the radius of turn, right? And try to reach a level where you will start either oversteering or understeering, right? And understand why your car is doing that. Once you do that, your test driver will exactly know how your car is behaving in certain situations, right? And he will then go tell your racing drivers what to do in a certain part of your track, right? You'll be lucky if your racing driver is also your test driver. In case he's not, then this insight will help you. It will also help your designers take decisions for the next year, right? Most common thing the teams do, and as a student, I've been guilty of it as well. The only testing we do is we directly go to a racetrack, we set up like a format, and we just try to go the fastest, right? Um, Although it is technically testing, it's not really giving your designers feedback that will help them improve next year's car, right? In your straight line acceleration, if you figure out things that you had assumed very early in your design stage, which you can change for next year, that will be massive benefit, right? And I realized that as a designer in my subsequent years, right? So just focus on the basics. The last thing you want to do is to build a track and do laps around it. Otherwise, it's just straight line, constant speed turns, or it is like figure of 8, or do like loops, right? Like do oval loops, right? Just keep doing these basic things to get your basics right. Then if you have aerodynamics on the car, you will want to test performance of your aero in the straight line and while cornering, right? So remove aero from the car, do a baseline test, put the aero back on the car, start doing tests at different speeds, right? And that will know if your aero is beneficial or not for you. Anything else you want to add to that?
No, not particularly. I mean, I think I briefly touched upon earlier as to like if you want to tune your car for different configurations, and how you want to set your say cell cutoff voltages, right? If you're doing a deep discharge on your vehicle, so say if you're drawing a certain number of amps from the battery, and that would drop your cell voltage below a certain voltage. While doing this testing, be sure that you observe those sort of like electrical effects on your vehicle also, so that you will probably know, right, that for the acceleration runs, this is the current that you will draw, this is how your voltage limits end up getting set. And there is a manufacturer setting, and then there is the setting. The manufacturer setting usually refers to to maximize the cell life, now without it being dangerous, right? So but you have to decide like which part of that spectrum that you want to fall on. So if you're going for endurance, maybe you don't need the acceleration, so your current draw won't be that high, right? So you could end up tuning your cutoffs differently, vehicle cutoffs differently. But if you're doing accelerations, and if you have a weak cell in the pack or something like that, you know that you might hit cutoffs. So you have to then think about, okay, what about cell voltage limits? Will I drop below the manufacturer's limits, or just some arbitrary limit that is set by default in the controller? So it'll let you discover these sort of BMS limits and things like that that you did not realize were there while doing some of this testing, and that will let you fine tune the software for the traction system that you will use on your system, on your race car. And it'll give you greater insight into, like, in what parts of the race what sort of tuning you want to use for the traction system itself. So it's sort of an addition to the points that Suraj just mentioned, but basically it'll let you understand the electric subsystems of your car also once you go through these rounds of testing.
Thank you, Suraj. Thank you, Hari, for participating today. We'd like to thank Ather Energy for hosting this session. Thank you to the teams and the participants that send in their queries, and to those on YouTube as well. We appreciate your participation. So thank you, and you all have a wonderful evening.